Okay, so in our last video, we looked at what an integral is and how we can use areas to find it. In this video, what we're going to do is look at some properties of integrals that we can use to solve problems when we know the value of an integral already. And we can use that value to answer further questions. So we did an investigation with this today in class, and hopefully it kind of helped you visualize what was happening. We're going to try to repeat and come up with some rules for that investigation here today. The first rule concerns the order of integration. Now, order means literally the order of the bounds. And what this rule says is that if you know that the integral from a to b of a certain function is worth s, say s is 5 or 7 or 9, then the integral from b to a, in other words, you flipped the bounds around, will just be the opposite number. We saw this in our investigation because we saw that when we found the area, we went the opposite direction. So when you go from b to a and you're going backwards, you end up with the opposite number. Now, we also looked at today the zero property. And what the zero property says is that if you're ever trying to integrate from a to a, so starting and stopping in the same spot, then the integral's value is 0. Now, this should make sense visually because if you're going from a to a, there's no place to go. You're kind of starting here and stopping here. So the area of a straight line is 0. Because there's no width to that area. We also looked today at what happens when we multiply our integral by a constant. So for example, if you know that the integral from a to b of f of x is s, then multiplying all of your y values by a constant just raises the y values of a function times that much. So you multiply your area by that constant. In other words, if you put a 2 f of x, your area is going to be worth twice as much because all the heights will be twice as tall. So our answer here would be k times s. And the reason is because the heights are all multiplied by k. So it ends up multiplying your total area by k. We also looked at the sum and difference rules. Let's say we have two different functions inside of our integral. So we have f of x plus g of x, or we have f of x minus g of x. Then what we can do is just get those two areas separately and either add them or subtract them depending on what our original problem said. So if we want to know the integral of f of x plus g of x, then we just add together the areas. Finally, we have the addition rule. So this had to do with adding the bounds. So instead of adding functions like we did in the sum and difference rules where we have f of x and g of x, here we have the same function but we're adding the bounds. And what this says is if you take the area from a to b plus the area from b to c, what you're really getting is the area from a to c. The key here is that the end of this first integral matches the beginning of the next integral. So if you add the areas, you get that total distance from A to C. All right, let's look at how some of these properties are used. So an example of a problem you might see with this is The directions say use the rules for definite integrals and the following known integral values. In other words, you know that these are the answers that you get when you do these integrals, but you don't know the graph, you don't know the function. We just know that the integral from -1 to 1 is 5. We know that the integral from 1 to 4 is -2, and we know that the integral from -1 to 1 is 7. If you know that, can you answer these questions? Well, if I want to know the integral from 4 to 1, what I realize here is that this is just the bounds of this second integral, but flipped around, which means the area will just be the opposite of this integral. So I would have -2, which is +2, because the bounds are flipped. And that was the order of integration property. Now, if I want to know the integral from -1 to 4, what I can do is sort of combine these two integrals. I know that from -1 to 1 is 5, and from 1 to 4 is -2. Since the end of this integral and the beginning of this one are the same number, I can combine them to go all the way from -1 to 4. So what I can do is just add up the 5 plus the -2, and I get 3. And this is the addition property. Finally, if I have from -1 to 1 and I want to combine 2 times f of x plus 3 times h of x, well, since I know -1 to 1 of regular f of x and -1 to 1 of regular h of x, I can just do 2 times whatever f was plus 3 times whatever h was, which gives me 10 plus 21, which is 31. And that's sort of a combination of the sum and difference rules and the constant multiple rules. If we look at another example, so I've got all this information. From 0 to 2 of f of x is 4, from 0 to 1 of f of x is 1, from 1 to 2 of g of x is -1, and from 0 to 1 of g of x is 3. And I want to know the integral from 0 to 1 of 2 f of x plus g of x. Well, I know the integral from 0 to 1 of f of x is 1, and 0 to 1 of g of x is 3. So I can use those same properties I used here and kind of use those values, the sum difference properties and the constant multiple properties. So I would take 2 times the integral from 0 to 1 of f, which is 1, plus the integral of g on those same bounds, and I would get 5. Now, if I want to know the integral from 0 to 2 of g of x, I can see I know from 0 to 1 and I know from 1 to 2. So the end of this integral is the beginning of this one, which means I can hook them together and add them up. So to go all the way from 0 to 2, I would do 3 plus -1, which would just be 2. Lastly, if I want to go from 1 to 2 of -5 f of x, well, what I really need to do here is -5 times whatever the integral is from 1 to 2. If I look at these properties, I know from 0 to 2 and I know from 0 to 1, but I don't know 1 to 2. If you think about this as being on a number line, I know what happens between 0 and 2, so I know this is 4. And I know what happens between 0 and 1. I know this is worth 1, which means if I want to know what happens between 1 and 2, I can subtract to get those. This is sort of an extension of the property we used here where we combined these two integrals. We could, if we know the whole thing, subtract to get a smaller piece. So to subtract, I would do 4 minus 1, which is 3, so my area would be -15. It's sort of subtraction instead of addition. Now here are some things you can't do. These are often places where students make a mistake. On the AP test, they'll say which of the following is false, and they'll choose one of these to be true instead of false because they don't realize that these are not allowed. So we thought we would actually take some time and tell you, like, this is what you're not allowed to do. There is no multiply property. If you have f of x times g of x, you cannot just do the integral from 0 to 2 of f of x dx times the integral from 0 to 2 of g of x dx. Not the same thing. That is not allowed. You cannot just change the bounds. Let's say I wanted to know in this problem the integral from 0 or from 2 to 4, where I just doubled both of these numbers. That would not be okay. So just doubling both of these numbers is not the same thing as doubling the integral. So you can't just double the bounds. That's not allowed. You can't multiply the bounds by 3. You can't change the bounds that are there. You can't just add constants. We actually saw this in our investigation today. When we added a number to the end of a function, we created a rectangle. So this is not the same thing as just doing the integral from a to b and adding a number. We have to add a rectangle instead. So we'll talk a little bit more about how to do that when we do some practice problems tomorrow. And you cannot just change x. So I'm allowed to multiply by a number to the y values, but changing the x actually distorts the function. I'm not allowed to multiply the x by 2. This is not the same thing as just multiplying the integral by 2. So that's not allowed. So there are a lot of things you're allowed to do, but there are also a lot of things you're not allowed to do. So it's really important to be aware of that and watch out for some of those common errors that students make. All right, well, guys, that's the end. Thank you so much for watching. I appreciate it. Have a great afternoon, and we'll practice some of this tomorrow.